Today, lesson 23A, we're going to work on finding the function rules given a graph. Yesterday, we talked about function rules given a table. And language objective is really the same thing as yesterday. And I'm not sure, but I think the why am I learning this may even be the same as yesterday. All right, so here's what we've been dealing with so far in Unit 2. We've learned how to determine if a relation is a function based on a set of data, which basically means a table or some ordered pairs or a mapping. We also talked about how to determine if a relation is a function based on a graph. We've learned different terminology for x values like domain and range, like input and output. And yesterday I added independent variable, dependent variable. We've also learned how to determine a function rule from a table of values. That was yesterday. And then also yesterday we quickly reviewed this idea of proportional relationships. So I want to make sure that I make the idea of a proportional relationship very, very clear. All right, so proportional relationships. First of all, they are linear. They go through the origin. They have equations that look like y equals kx or y equals mx. M and k are just both referring to the slope. And the other idea here, and I would like you to add this somewhere in your notes about proportional relationships, that their ratios of y over x are all equivalent. And I just do it somewhere off to the side. I talked about those first three in detail yesterday, but the other piece of it is that the ratios of y over x are all equivalent. And what I'm going to do here before we actually get into today's lesson is I'm going to show you two tables from yesterday, and I'll show you a way of looking at the ratios to prove whether something is a proportional relationship or not. All right, so here was a problem from last lesson. This ended up being having a function rule of y equals 2x. We talked about the fact that, yes, that is a proportional relationship. But let's take a look at the ratios of y over x. The ratio of y over x for the first ordered pair is negative 2 over negative 1, which is what? It's what?
2.
It's 2. Now, the 0, 0 doesn't really help us because that's undefined, so I'm not even going to look at that one. And then we have this ratio right here. What's 2 over 1? And what's 4 over 2? Are all of those ratios, with the exception of 0, 0, are all of those ratios the same?
Yes.
That's the other piece of what a proportional relationship is. Okay? But let's look at number 7 from yesterday. We came up with a function rule of this, and we looked at the graph, but now let's quickly look at these ratios here. We have y over x. Negative 5 over negative 2 is 2.5 or 5 halves. The 1 over 0 doesn't help us because it's undefined. And then we have 7 over 2. Is that 2.5? Yes or no?
No.
What is it? 3.5 or 3.5. And then we have 13 over 4. Well, that's not 2.5 or 3.5. That is, what is it? 3 point what?
2.
It's 2. I heard somebody say 7.5. It's 2.25. The point here is this. The other piece of whether something is a proportional relationship or not is looking at the ratios of y over x. If all these ratios are the same, it is a proportional relationship. But if they're different, and we really could have stopped right here, because we already knew at that point that they were different. If they're different, it's not a proportional relationship. All right, so I just wanted to clear that up. All right, so here's the first problem for today. Find the function rule given that graph. It should be obvious, and notice how I put in parentheses equation. Yesterday I gave you a few problems in the homework where instead of asking for the function rule, I asked for the equation, because they're the same thing. The function rule is the linear equation for a situation. So, in case you've forgotten, in order to find the equation of that line, we need the slope. We need the y-intercept. Could somebody please quickly tell me what the slope of that line is? It's 2/3. Is that what it is? Let me look here. 1, 2, 3. We rose +3. How many am I running? Most of you are looking up here, which is fine, but I think that graph is in your notes. Is it? Oh, it's not. Okay, sorry about that. 1, 2, 3, 4, 5. So the rise over the run is 3/5. So the slope is 3/5. What's the y-intercept? Just say it.
-2.
-2. So that's all we need in order to find the equation of that line, which happens to also be the function rule. So the function rule for that situation, that graph, is y equals 3/2 x minus 2. All right, everybody, quickly try number 1. So remember, we are finding the slope, and we're finding the y-intercept. So what is our function rule for this graph? Yes?
The function rule is 2x plus 3.
Okay, and I'm glad he said that. I'm glad he said that he used the sentence frame, the function rule is, but he said what a few of you did in the homework last night. He said the function rule is 2x plus 3. Is that the function rule?
No. The function rule is y equals 2x.
Yeah, we can't forget the y equals part. Plus, we have to write the equation of that line because they represent the same situation or the same thing. Slope is 2, y-intercept is 3, so the function rule is y equals 2x plus 3. By the way, is this a proportional relationship?
No.
Raise your hand if you can tell me why it is not a proportional relationship.
It has the plus 3, which means it will not go through the origin.
There you go. It doesn't go through the origin. It goes through positive 3 instead. It's not a proportional relationship. All right, everybody try it. Number 2. So I'm having you do number 2 and number 3 at the same time. I think that finishes off the idea of when we actually have our dots as ordered pairs. Then we'll deal with the ones that don't have the dots on your coordinate plane. All right, function rule for number 2. Yes?
Y equals -4/3 x plus 3.
So you want to sentence frame that for me?
The function rule for this graph is y equals -4/3 x plus 3.
Slope is -4/3. Y-intercept is positive 3. So the function rule is y equals -4/3 x plus 3. Is this a proportional relationship? Yes or no? No, it is not. All right, so this is what number 3 should look like. So can you fix that in your notes really quickly and then find the function rule? All right, function rule for number 3. Yes?
The function rule for this graph is y equals 5/2x minus 3.
Slope is 5/2. Y-intercept is -3. There does not have to be a dot there. Obviously, it's just where the graph crosses the y-axis. So the function rule is y equals 5/2 x minus 3. Sometimes we just have a line there, and we have to sort of figure out where the perfect ordered pairs would be. So let's take a look at number 4. Could somebody give me one perfect ordered pair? And in my opinion, when you have a graph like this, you should go ahead and fill the dots in, or 2 of them, because that's really all you need. Yes? 4, 0. So that would be right there, right? And we just need one more. Where's another perfect ordered pair?
0,4.
0, 4 right there. And regardless of whether there are more on there or not, which in this one there are a lot more, that's all you need in order to find the function rule. So let's finish this one off. Now remember, we could have used this one, we could have used this one, we could have used that one, we could have used this one, and there are lots of ordered pairs that we could use in this one. But what we're trying to figure out is what the function rule is. What is the function rule?
The function rule is y equals x plus 4.
Y equals x plus 4. Let me tell you how I know that that is not right. That line is going downhill from left to right. Therefore, it's supposed to have a negative slope. Yes? You said the function rule is -1x plus 4. Anybody want to change that? Athena?
The function rule is y equals -x plus 4.
You left out the y equals, I think, Morgan.
Oh, I thought I said.
I didn't hear it. If you did, I didn't hear it. Okay, the function rule is y equals negative x or negative 1x plus 4. All right, go ahead now and do number 5 and number 6. Number 5, we need to find a couple of perfect ordered pairs. There are more than a few on that graph, but either way the slope is 2, y-intercept is 0. The function rule is y equals 2x. Is this a proportional relationship? Yes, it is. Number 6. The slope here is negative 1/3. The y-intercept is negative 1. Our function rule is y equals negative 1/3 x minus 1. Is this a proportional relationship? No, it is not. All right, so number 7 and number 8, you need to first start by plotting the two ordered pairs. So what this is kind of like is it's kind of like the problems we did yesterday, but where we would maybe only have a table with two ordered pairs in it. But since we're taking the idea of graphing, let's plot both of those two ordered pairs. And I know that I didn't pass out rulers to you, but you should be able to figure out easily what the slope is. And you'll just have to be careful on the drawing of your line to figure out where your y-intercept would be. So let's go ahead and do that and figure out what the function rule is. Function rule for number 7, what would it be? Yeah.
The function rule is y equals x plus 2.
X plus 2. So you're saying the slope is 1?
Yes.
Okay, let's see if that's right. I'm going to plot both of those two ordered pairs, draw my line through. I can see right there that the slope is 1. Is there a different way that you could have found the slope without the graph?
You would have done y2 minus y1.
Yeah, the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But either way, slope is 1. We can see from the graph the y-intercept is positive 2. And so therefore the function rule is y equals x plus 2. All right, number 8. Same thing. All right, function rule for number 8. What should it be? Yeah.
Y equals, or the function rule for this graph is y equals negative 2x minus 1.
Very good. Slope will be negative 2. Plot those two ordered pairs, draw a line through it. Much easier if we have a ruler. But regardless, should be y equals negative 2x minus 1 for the function rule. All right, quickly turn to your shoulder partner. What did you learn today?